Hi, I'm Alex Lex. I'm a new assistant professor at the School of Computing at the University of Utah.
I'm Tucker Hermans. I'm an assistant professor in the School of Computing.
I'm Ryan Stutzman. I'm an assistant professor in the School of Computing at the University of Utah.
So I went to school in Austria and I graduated from a university in Graz, and then I spent a couple of years in Boston at Harvard as a postdoc and as a lecturer.
So I grew up in northern Indiana in a small farm town of about 5,000, and I did my bachelor's degree at Purdue University, and then I went on to do my grad work at Stanford.
I grew up in Texas, in a medium-sized town outside of Austin. From there I got my undergraduate degree in computer science as well as German at a small college in Maine. Then I went to Georgia Tech in Atlanta and got a PhD in robotics.
So my research is about visual data analysis. The idea being that with all the data that we currently acquire, we need algorithms and we need databases and so on, but we also need humans to make decisions based on the data. And I'm working on the interface between the computer and the human, and how the computer communicates the data to the human with visualization.
My research in robotics focuses on how can robots use sensing to understand their environments. And then from these models and representations of their world that they're building, how can robots gain experience autonomously so that when they're faced with new situations or the same situations but slightly altered, they can perform better than if they didn't have this experience.
So I work on large-scale software systems that run on thousands or tens of thousands of machines, and the key idea is that in the future we really want applications where people can interact with massive data sets much more rapidly and interactively than they can today. So I really work on database systems that run on many machines and provide access times that are thousands of times faster than today's systems.
I first learned to program when I was around 12, and I was always very inquisitive about what's operating behind the scenes here. I learned first to program in Java on just kind of a standard, a Gateway 2000 computer, something that I don't think is around anymore.
My interest in computer developed probably later than for most computer science professors. I wanted to go to law school until I was 18, and then I made a deal with my parents, who own a company, that I would go to a technical college for 2 years. So I did mechanical engineering and computer science there. My parents wanted me to do mechanical engineering, but somehow computer science was more interesting. So I decided after this 2-year college, okay, I do need to go to a full-fledged university program, and I do need to do computer science. That really was what excited me.
Of course, like almost all kids, most of the things I wanted to build revolved around games. So usually it was trying to find ways to kind of get the hardware to do something more exciting in the game. We were often trying to kind of push the limits of what the video hardware could deliver to kind of create new effects and things in the games we were creating.
One thing that was very attractive about the University of Utah is the fact that the same robotics tracks for graduate students, both in computer science and mechanical engineering. Having the ability to have students with this kind of diverse background, it allows me to kind of have a broader view of the kinds of problems I can work on. It's exciting because I can work with students who are very capable in a field that's not exactly where I have my expertise, right? So I don't know how to maybe design hands very well, but if I have a really talented mechanical engineering student, that's something I could start working on.
The School of Computing and the SKI Institute are both really well-known places to do computer science. SKI especially has an immense reputation within the field of visualization, but what really specifically drew me here is that there's other faculty who have shared interests, and there's already a culture of visualization here. There's people that I can interact with from the start. I don't really have to bring in my own PhD students to have somebody to talk to, but I actually can rely on all the resources that are already here.
But I think the main reason I ended up here is because I could really see how I fit into the department. I could see kind of what I would do to complement the other people who are already doing research here. So it really felt like when I showed up here that people were really interested in seeing me succeed, and they really had ideas on how they could help me succeed as well.